Vaitarna Bridge, connecting Safale with the main district road and subsequently to the Mumbai-Ahmedabad highway, was constructed during the years 1985 and 1988. The bridge consists of 8 spans. The main spans are 45 meters each, while the end spans are 25 and 30 meters respectively. The total length of the bridge is 325 meters. The foundation of the bridge is a well foundation and the substructure consists of 7 RCC piers, P1 to P7. The superstructure consists of RCC box girders. The width of the carriageway is 7.5 meters. In the year 2014, it was found that the pier P5 was tilted by about 15 to 20 centimeters on the upstream side. The neoprene pads were also displaced and the superstructure was dislocated. A zigzag vertical crack was developed in the well up to the well cap. The width of this crack was nearly 30 centimeters at the bottom and 4 to 5 centimeters at the top. The problem had been created mainly due to the sand dredging carried out over a period of many years. This had eroded substantial part of the base of the well foundation of P5. Only 30% of the area of the well bottom was resting on the rock and it was in a destabilized condition. Also, the depth of the water had increased by 10 to 12 meters. This animation showcases the innovative solution that was used, the implementation of which was a big challenge. It was important to stabilize the well foundation of P5 to avoid further tilting before the actual rehabilitation work could commence. The scheme prepared for immediate stabilization of P5 was as follows. Initially, the gap between the well bottom and the ground was filled up by inserting wedge-shaped precast M40 RCC sleepers of required sizes in layers. The remaining gap was filled with MS plates. The loose material on the sides was cleared with air compressed pressure. Next, RCC ring beam of size 500 mm by 500 mm was cast underwater with quick setting adhesives. In the next stage, cement grouting was carried out at the bottom of the well with required pressure using mechanical equipment. The depth of the water was about 15 to 16 meters. Hence, expert scuba divers had to be engaged for this work. The stabilization was done to stop further tilting of the existing well and also to bring the existing tilting within the permissible limits as prescribed by IRC Code 78. After this, it was time to commence the rehabilitation work so as to provide alternative support to the superstructure and abandon the existing pier well. Accordingly, it was decided to provide RCC piles of 1200 mm diameter on both upstream and downstream side of P5. A total of 12 such piles were planned, with 6 piles on each side of the pier well, till the height of well cap. The average height of piles up to cap level was about 17 meters, while the socketing depth in rock was approximately 5 meters. Thus, the total height of a pile was about 22 meters. While socketing, it was important to keep the constant pace of execution, as due to hard rock, a pile excavation was about 20 to 22 centimeters per day or night during high tide and 25 to 30 centimeters per day or night during low tide. Hence, it took almost 15 to 20 days on an average to achieve 5 meter socketing depth for one pile. Considering the urgency of work, the piling was continued even during monsoon, except on high flood days. The pile cap was of suspended type with depth of 1.8 meters and weight of about 55 metric tons. The form work was designed in such a way that it provided supports from the pile itself. 52 steel bars of 32 mm diameter were used for reinforcement of piles. Circular monolithic RCC columns of 1500 mm diameter and 2250 mm height were cast over the pile cap to support the portal beams. Rectangular portal beams were cast except in the middle portion of the existing RCC pier. The superstructure was lifted by hydraulic jacks and was temporarily supported on portal beams. Later, the existing RCC pier was dismantled so as to cast the remaining portion of portal beam. Meanwhile, the light vehicle traffic on the bridge was suspended to carry out the replacement of expansion joints and the bearings. After curing period of 28 days, the pedestals for bearing were cast and neoprene bearings were provided. Finally, the superstructure was lowered on bearings. During this period, the inspection of superstructure and external pre-stressing was carried out using different tests. Necessary repair works were carried out simultaneously based on the test results. The observation of one vigilant engineer was picked up by the top authorities at PWD with all seriousness. The right thinking and swift action on their part has not only strengthened the bridge, thus increasing its longevity, but has also averted a possible mishap.